Hi, good day everyone. Here we are again solving math problems. For whatever reason, some of you are trying to learn new techniques, others maybe are just enjoying the process. And I hope that whatever it is, whatever your reason is for joining this lecture, I hope you will again learn something from today's discussion. So for this video, we will talk about some special inequalities. Let AI and BI be real numbers for I equals 1 to n. Then we have 4 inequalities in this video. The first one is the arithmetic geometric mean inequality, or AGMI. It states that the nth root of the product of a sub 1, a sub 2 up to a sub n is less than or equal to the average of the sum of or 1/nth of the sum of a1 plus a2 plus an. Or you can also say it is less than or equal to the average of the AIs. The second inequality is Cauchy's inequality, or sometimes called Cauchy squares inequality. It states that the square of the sum of the products of AI BI is less than or equal to the product of the squares of the product of the sum of the individual squares of AI and BI. And then the third inequality is called the triangle inequality, which I think is more familiar to many of you. The absolute value of the sum of AI from 1 to n is less than or equal to the sum of the absolute values of the individual AIs from 1 to n. A special case of this triangle inequality is when you have a square root. If AI is positive for I equals 1 to n, then the nth root of the sum of the AIs is less than or equal to the sum of the square roots of the individual AIs. And then the fourth inequality is called the Bernoulli's inequality, which states that if x is greater than 1, then the binomial 1 plus x to the n is greater than or equal to 1 plus nx for all n positive. So our first problem is, if x squared plus y squared plus z squared is equal to 107, where x, y, and z are positive, what is the greatest possible value of x plus y plus z? Okay, so each of x, y, and z has coefficient positive 1, because x is equal to 1 times x, y is equal to 1 times y, and z is equal to 1 times z. So by the Cauchy's inequality, x plus y plus z squared is equal to the sum of the squares of the ones of the coefficients, which are all ones, times the sum of the squares of the variables, x squared plus y squared plus z squared, which is given to be 107. So this is 3 times 107. So you have 321. Therefore, the conclusion of the Cauchy squares inequality, this is the conclusion. However, from which we obtain x plus y plus z is less than or equal to the square root of 321. Since x, y, and z, or no, not since. If x, y, and z are integers, then x plus y plus z is less than or equal to 17, which is less than the square root of 321. Okay, second problem. If A, B, C are positive real numbers such that AB times BC times AB plus BC plus CA equals 12, find the smallest possible value of A plus B plus C. Okay. So we have A plus B plus C squared is equal to A squared plus B squared plus C squared plus 2AB BC plus CA. Which is equal to A squared plus B squared plus C squared plus 24. Since AB plus BC plus CA is equal to 12. And by the Cauchy squares inequality, this is greater than AB plus BC plus CA plus 24, which is equal to 12 plus 24 equals 36. That is A plus B plus C is greater than or equal to 6. Okay, so that's it for this video. However, I would like to give a challenge. So this is the challenge. For x positive or 0, what is the smallest possible value of f of x, which is equal to 9x squared plus 36x plus 52 over 12 times x plus 2. Again, the solution to this challenge will be given in the next video. So, however, before you go to that video, try to solve this problem yourself first. So that's it for today. Thank you for bearing with me. I hope you enjoyed our discussion today, and God bless.